Okay, so for number 7, we want to find the slope of the parametric curve x is equal to minus 2t cubed plus 1, y is equal to 3t squared for t between negative infinity and positive infinity at the point corresponding to t is equal to 2. So now this graph, the graph of this curve, whatever that looks like, it's going to be in an xy plane. So this is not the actual look of the curve, I'm just drawing something random, but for you guys to see that at whatever point I put a slope at, that slope is a slope that exists in the xy plane. So that's a slope that is dy dx. This is our regular derivative of y with respect to x. So to find the slope, we do need to put the derivative of y with respect to x. However, we do have a problem here, right? This problem is that y is not we don't have an equation where x is the input and y is the output for us to do dy dx. What we have instead is two equations where t is the input, one where x is the output and the other where y is the output. So what we're going to do here is we're going to take the derivative of both, and let's begin with this equation over here. So this is going to be dy dt because t is the input and y is the output. And that's just going to be, so we bring the 2 down, so 3 times 2. So that's going to be 6t. And then we're going to take the derivative of x with respect to t. So we have dx dt, because t is the input, x is the output. And that's going to be minus 2 times 3, which is minus 6 times t squared. So once we have this, remember that we're looking for dy dx, which is the slope in the xy plane. So to find dy dx, we're going to use this algebraic trick where we're going to do dy dt divided by dx dt. And if we do this, we can see that the denominators, they cancel out because they both have the same denominator. So that's going to be equal to just dy over dx, which is what we're looking for, right? And so dy dx is the same thing as going dy dt over dx dt, so let's divide that. Remember that dy dt is this guy here, so that's going to be 6t, divided by dx dt, which is now this guy, divided by minus, that's going to be minus 6t squared. So if we cancel things out, the 6's cancel out, we're left with minus 1 on top divided by t. So dy dx is going to be minus 1 over t. That's the general form. And now we want to evaluate it where t is equal to 2. So we're just going to plug in 2 for t. So dy dx is going to be equal to, at the value t is equal to 2, so that's going to be equal to minus 1 over 2. So this, let me erase some of this. So this here would be our final answer, right? We'd just plug in 2 for t. And that would be the slope at the point t is equal to 2 for this parametric curve.